Guys. All right, sorry guys for my vote kids who are, I forgot to record, so we're on example 2, all right? Here we go. So if we want one of our variables to be eliminated, we're gonna have to fix this, right? So if I look at my x's, this has a 1, this has a 5. Go to the little number. Can you multiply the little number by something to become the opposite of the big? So I need this to be a negative 5x. What could I multiply this by to make it a negative 5x? A negative 5. So one option in order to get my x's to eliminate is just to times the entire bottom equation by negative 5. All right, let's see. Maybe the y's are better. If I look at the y's, I do like that they're already the opposite signs, so I won't have to mess with their signs. So if you ignore the signs, go to the little number, 2 and 3. 2, can you multiply 2 by anything to become a 3? No. So that means if the little number can't become the big number, you have to change both of them. You have to find a number that 2 and 3 can both become through multiplication. Well, guys, there's lots of numbers that 2 and 3 can both become. The smallest number is 6. So I'd have to make something a 6y and then another one a negative 6y in order for my y's to eliminate. So the easiest thing to do is get rid of x, because to get rid of x, I only have to change one of the equations, not both. All right, so that's what I'm going to choose to do. I'm going to times the bottom equation by negative 5 so I can eliminate my x's. All right? So, oh, hold on one second. Guys, hold on one second. Hello? I thought it was the name of somebody. Okay, we're good. I got a new phone, guys. I'm pretty big time. All right, so we got negative 5 times x is negative 5x. Negative 5 times negative 3y is 15y's. And then don't forget about this y. Everybody always forgets about him. Negative 5 times negative 3 is positive 15. Now you can bring the top equation down. We didn't even have to change him. Now look at that. That's beautiful. Same number, opposite sign. Plus 2y equals 19. Add them together. Let's see what happens. Our x's are eliminated. We get 17y's equals 34. Now all we have to do to get y by itself is divide by 17. And then we find out that y is 2. Perfect. So now we can get x by, like I said, you can plug it in here, solve for x, plug it in here, solve for x. Or guys, if you're like, I hate plugging in, then start over and eliminate y's this time by getting a 6y and a negative 6y. And then you don't have to plug back in if you don't want to. I don't mind it. I'm going to plug into the bottom equation, and I'm going to get x minus 3 times 2 goes in for y, and then it equals negative 3. So x, negative 3 times 2 is negative 6 equals negative 3, and then all I have to do is add 6. Okay, and then x equals 3. So now I know x has to be 3 and y has to be 2 to make both of these equations true. It also means they would have met at the point 3, 2. Okay? All right, perfect. 2 more and we're good to go. Let me just ask, does anybody have any questions? Everybody okay? Thumbs up, we're moving along. Okay. Guys, you guys are good here? All right, last 2. All right, so in example 3, if I want to solve this system using the elimination method, right? The elimination method wants us to add the equations together. If I was going to add them together right now, I'd have 14 x's and 7 y's. Nothing got eliminated, which means I'm not ready to add them together. So, oh, it's my HVAC guy. Holy crap, this is turning into a crap show. Hold on. Hello?
So glad you started recording, right?
Hey, Aaron, what's going on?
You want to take over this?
No, I don't. It's been a long time since I taught this, Kyle.
Okay.
Oh. You can teach history. What do you want to talk about? I'm teaching the Revolutionary War. Let's go.
All
What do you want to ask me?
I don't even know what I'm doing.
What'd you say?
I don't even know what I'm learning in history.
You don't?
I think the Great Depression.
Yes, probably. Sounds like it. Yeah, what are we? January? Yes, you should be on the Great Depression. Miss Cranston also doesn't mess around. She keeps it moving.
I know.
So she doesn't diligently push
Very,
it.
very, very fast paced.
Yeah, she's fast. I used to teach, I don't have a math degree, I teach special ed.
Mhm.
But I used to teach, Algebra 1, when I taught with Mr. Bianchini, we would trade off. I'm not a good math teacher. I can teach you straight all day math. I can look what you guys are doing, check it, answer questions. I cannot explain it the way that Mrs. Hardy can, ever. Because she's also very, here's why you do this. I'm like, I don't know why you do this. Just do it.
Like, trust me, it gets you the right answer.
Right,
I don't know
yeah.
why, but do it.
That's all. And sometimes I'm wrong, totally, for sure, 100%. They don't have enough math teachers that teach special education to do this. And I've been doing this I've been working with Ms. Hardy for 7 years. And with Mr. Bianchini for 4 years before that. So 11, the whole 11 years that I'm here, actually. So.
Sorry. I am so sorry, guys. I can't ignore that call. It's just, are we done? I don't even know. All right, so I think I said if you added them together right now, you weren't ready. So we need to get rid of X or we need to get rid of Y. I suggest whichever one is easier. So I always kind of go through my options. If I want to eliminate my X's, both of them are positive, so I'm going to have to make something negative. It never matters which one. I go to the little number. Can I multiply 6 by anything to become 8? No. So now you'd have to find a number that both 6 and 8 can both become, and you'd have to change both equations. Well, guys, there's lots of numbers that 6 and 8 can both become. Pick the smallest. The smallest number is 24. So I'd have to make one 24 and one of them negative 24 in order for my x's to eliminate. All right, what about y's? Maybe y's are easier. If I want to eliminate my y's, they are both positive, which means I'm going to have to make one of them negative. And if I look at the little number, I can't multiply 2 by anything to become 5, the bigger number. So that just means, again, you're going to have to change both equations. So no matter who you eliminate, we have to fix both of the equations. Well, what number can 2 and 5 both become? Again, there's lots of them. The smallest one is 10. So it just comes down to, would you rather work with 24s or 10s? I'd rather work with 10s. So I'm going to choose to eliminate y because it's just smaller and easier numbers to work with. All right, so I'm going to make this one a 10 by multiplying the whole top by 2. Then I'm going to have to make this one my negative 10 because one of them has to be negative. So to make this one my negative 10, I'm going to have to times the bottom equation by negative 5. So let's do it. So I'm going to get 16x plus 10y, because that's what we were shooting for, equals 44. And then I'm going to times the bottom by negative 5. I'm going to get negative 30x minus 10y. That's what we want. Look at that. That's beautiful. Equals negative 5 times 13, negative 65. Add them together. I'm going to get negative 14x's. My y's will cancel and eliminate from the problem. And then they equal negative 21. And then all I have to do to get my answer is divide by negative 14. And then x will equal, unfortunately, negative 21 does not divide evenly by negative 14, but it will reduce to a positive, and both of these numbers divide by 7. So it becomes positive 3 over positive 2. So 3 halves or 1.5. I think the homework asks for the fraction. All right, so we get 3 halves. So now you can either plug it back in and solve for y, or if you're like, damn, I ain't plugging a fraction back in, I don't want to deal with that, then start the whole problem over, but get your 24 and your negative 24, and you could eliminate x this time. And then you never have to plug back in. I don't mind plugging back in, so I'm going to plug back in. I'm going to plug into the bottom equation, and I'm going to get 6 times 3/2 goes in, plus 2y equals 13. I'm going to put 6 over 1 to multiply my fraction. 6 times 3 is 18 over 1 times 2 is 2. 18 over 2 is 18 divided by 2. That's 9. So I'm going to get 9 from that, plus 2y equals 13. Now we're in business. Minus 9. And you get 2y equals 4. Divide both sides by 2. And y is 2. And I swear to you, y is not always 2. It just happens to be 2 in all of these examples. All right? So then that means that these two lines would have met at the point 3/2, 2. Okay? All right, last one. I am so sorry. I'm sure some of you have already gone ahead, and I don't blame you.
I would have gotten it right if I had done it.
See, you should have jumped right in there, Miss Greenhouse.
I'm not confident.
Yes, you should be. She is a math teacher, guys. She is not in the history department anymore. All right, the last example. I just want to warn you. You should look at it and be like, what the heck? It should look off. When it comes to the elimination method, this is what you want it to look like. You want x's, y's equal to a number so that everything lines up. So when you get a problem like this, there's a couple problems on your homework tonight on the Delta Math where you're going to have to rearrange things first to get it set up for the elimination method. So for example, if you look at the top equation, I need x and y to be on one side of the equal sign and then the 7 to be by itself. So I'm going to add my 3x's over to move them onto the same side as the y's. So I'm going to have to add these 3x's over, which is going to get me positive 3x now, minus the 6y that was already there, and then it will equal the positive 7 that I left on the other side. All right, then if I look at this equation, again, I want x and y to be on one side of the equal sign and the number by itself. So I'm going to have to add my 2y's to be on the same side as my x's. All right, and then it's going to get me negative x plus 2y equals the 6 that I left over there. So guys, there are a couple questions on your homework where you're going to have to rearrange first, then you can start the whole elimination process. All right, so if I added them together right now, nothing would happen. I'd have 2 x's and negative 4 y's. It's not ready. I need the same number but opposite sign in front. So if I look at my x's, one's positive and one's negative. I like that. Well, if I look at the little guy, what can I multiply a negative x by to cancel with him? A 3. If I could make this a negative 3x, then it would cancel with my positive 3x. All right? And then just while we're here, what about the y's? If I wanted my y's to eliminate, they're already the opposite sign. Could I multiply a 2y to become a 6y to cancel with this? Yeah, 3. So it looks like no matter what I choose, I need to multiply the bottom equation by 3. So if I multiply the bottom equation by 3, I get this. Negative 3x plus 6y equals 3 times 6, 18. All right? Bring over the top equation that we didn't even have to change and watch what happens. If I add them together now, my x's eliminate and cancel from the problem, but so do my y's. And we probably didn't plan on that happening, but it happened. So guys, if everything cancels over here, that means there's nothing left. And what represents nothing? 0. There is 0 left on the left side. And it is equal to 18 plus 7, 25. Is that a true mathematical statement? Does 0 equal 25? No. So that means this is what it's going to look like when you get no solution. If your variables all cancel out, but your numbers don't, then that means you're always going to be left with 0 equaling something it doesn't. And that's always going to end up as a no solution because it's not true. If you are going to get IMS, then your variables are going to cancel, and so are your numbers. Everything cancels, and you'll be left with 0 equals 0. And that's true. So if you're going to get IMS, everything has to cancel, and you have to be left with 0 equals 0. Okay? All right. Is everybody okay at home? Everybody's good? I apologize for the pause there. You guys okay? All right. So again, this is usually a pretty good method for you guys. It's more of a review than it is kind of reteaching you anything. All right, you have homework tonight on Delta Math. It's 10 questions. It is due tomorrow by 11:45, all right? If nobody has any questions, Ms. Greenhouse, did you take attendance? Then you guys are good to go, and we will see you guys tomorrow. Thanks for coming. Thanks for being here.